My name is Lars Brinkhoff, and I have the honor today to interview Barbara Liskov. We are going to talk about the early development of the CLU programming language, and at the end I will present a small Hello World example using a PDP-10 emulator. Hello Barbara, I'm very happy to talk to you.
Nice to talk to you.
First, I understand CLU was influenced quite a bit by Lisp. In your CLU history paper, you write that you have used Lisp extensively. Was
Uh,
that during
yeah,
your time at Stanford?
yeah. My thesis was written in my thesis program was written in Lisp, so I was very familiar with programming in Lisp,
Right.
and it was both good and bad. The bad part was it didn't have any type checking, and so I would sometimes find errors after lots of looking that could have been detected by a compiler that did type checking. On the other hand, it's a very flexible language, and it also um, was different from other languages at the time in two important ways. It used the heap rather than the stack for storing data. And it really depended on modularity in the sense that you just kept writing different procedures and they called one another, as opposed to a big block structured program with lots of global variables that were being shared by all the code.
Right. Um, which machine was Lisp running on at Stanford?
Uh, I think it was a B5500, maybe
Okay.
a stack machine.
Right.
It's a long time ago, but yeah.
Did you also see or use the PDP-1 or PDP-6 at McCarthy's AI lab?
I think that we had moved on from there, but I'm not absolutely certain. Other people might have been using it,
Okay.
but I don't think I was.
Right.
But honestly, I wasn't paying much attention. So
Okay.
yeah.
What was programming like at that time? Did you use punch cards or teletypes?
Well, by the time I was working on my thesis, we had a little time sharing system working, and so I could use a type, basically a teletype. I could
Right.
enter my program, and I could get printouts.
Okay.
Yeah. I mean, of course, earlier we were using punch cards, and I can remember in the compiler course I took at MIT, we would take over the machine at night, the whole class, and we would come in with card decks because it was the only and run our card decks through the computer because it was the only way we could get the fast enough turnaround to get our code running in time.
Right. Okay, so I understand you first came to MIT in 1972. Um, it seems you were somehow associated with Jack Dennis' computation structures group. Is that correct?
No, that's not really correct. But what happened was Jack was very helpful to me. I was initially put on the AI floor, and I think there was some sort of thought that I was going to move back into AI, but by now I was working in systems, program methodology. And Jack helped me get back down onto the systems floor. And he was also very helpful. I think he was just very encouraging and helped me sort of get myself settled at MIT. He used to come to all the CLU design meetings, and so he was just he wasn't really a collaborator, but he was just helpful.
Okay, because I see many of your memos are in the CSG groups.
It could be, I really we shared a secretary, and in those days, of course, memos were typed. They weren't. You
Right.
didn't on typewriters with right. Yeah, so I had forgotten about that, but yes.
Okay. But there are also some kind of association with Licklider's dynamic modeling group. But at least you were using their PDP-10 computer.
I was using their computer. What happened was computers were, expensive resources in those days, and I didn't have one of my own. And so they agreed to let me use their computer in exchange for us using MDL, Muddle, we used to call it, which was a Lisp dialogue. So we did the first implementation in MDL.
The PDP-10, it ran the incompatible time sharing system. I'm just curious, I understand there were two ways to pronounce the short form, ITS or ITS. Which did you prefer?
The only one I was actually aware of was ITS.
Right.
Yeah.
That's a common one.
Yeah.
Okay, you wrote in your CLU history paper that you first used Lisp. Did you use Mac Lisp for that?
I used whatever Lisp was running on whatever computer I was using at the time.
Right.
So again, I wasn't paying much attention to details like that.
Right.
Our strategy for implementing CLU was to bootstrap.
Yes.
So as fast as possible, we got up a little tiny subset of CLU using a compiler that was written in either MDL or Lisp. And after that, we were doing development in CLU itself.
All right. You wrote that you were forced to change to MDL due to political reasons, but I guess that was in exchange for using the dynamic modeling PDP-10 then.
Yeah.
Right. Okay, at that time, what was programming like at MIT? Were you still using teletypes, or did you use the graphical IMLAC terminals?
I'm trying to remember. I know that we had a Dover. So we were one of the earliest. I think they got the Dover in 1972, and we were one of a very small number of places that had a sort of a beta version of the Dover.
Yes.
We were able to get good printing, which was nice. I don't remember. I kind of think I had a terminal with a display, a big fat one.
Right. Yeah, they were big at the time.
Yeah.
Maybe it was also a VT52 text terminal.
Well, you see, you keep bringing up these hardware terms, and I was not
sorry
to particular pieces of hardware.
Right.
Yeah.
IMLAC sounds familiar.
Yeah, they were popular with that particular PDP-10.
Yeah.
Okay, as an aside, much later, I understand you acquired some Backstation 100 terminals, the graphical terminals, which led to Bob Scheifler starting the X window system. So CLU had a big impact on how graphics was done on Unix.
I don't remember. Dorothy, do you remember all those facts?
Yeah, okay, we can't hear you, but I think you're getting into talking about Argus, which is a system for distributed programming.
Right.
And Barbara's group built that up, and it was very difficult to keep track of what was going on each machine. So Bob Scheifler built this window system so that you could have a little window for each machine, and so figure out what was going on and debug it and start and stop different things on different machines.
Okay, that's cool.
So Argus was very similar to CLU, but had
right.
extensions for multiple machines.
I'm going to do my little demo now. So I'm going to share my screen.
Mm-hmm.
Okay. Here we go. So this is a terminal emulator connected to a PDP-10 emulator, which is running ITS. And thanks to files from backup tapes stored at MIT, we have a version of CLU from 1978. So I'm going to log in. Right, another question. Your group wrote their own text editor called TED. Was that your preferred editor, or did you also use TCO, RMode, or Emacs?
At the time, TED was our preferred editor. I believe Russ Atkinson was the one who invented TED.
Okay.
And it was pretty similar to Emacs. So after a while, we switched to Emacs. Yeah.
Yes. Okay. Well, I just know Emacs, so that's what I'm going to use. And we're going to use the built-in CLU programming mode. So I'm going to write a small procedure. It doesn't have any inputs or outputs, so it just writes a string. So this is before the standard stream clusters were made, so it's file instead. And file TUIO, that refers to the primary output stream. And we have a new line character there that looks pretty much like C. So there's the small, very small hello world example. So we're going to compile this. Compiler is called CLU. And as we can see, it's from early 1978. We can type help to get a little help.
Same as...
And the one we want would be compile. So let's use that. And it seems to be a success. So there's also a quit command. And this is somewhat interesting. We get a colon. And now that's pretty much similar to a Lisp listener, because we can enter small expressions. And this is a small CLU expression we can type here. But we're just going to leave the CLU system like this. So we can now see we have hello CLU, the source file, and hello bin, the compiled program. So at this point, we might expect to use a linker. But as far as I understand, there was no linker yet at this point in time. So we are going to start the CLU runtime system. And
So
what
are the control keys?
That's ITS for starting a program.
Okay.
It's kind of different, but I like it. So here we're going to load the hello bin file. And there is a function called fload. That's actually just like in MDL, so maybe there was an influence there. And the file has loaded, so we can now run the procedure. Hello world. But we can do a little bit better than this. We want a standalone executable all the way from the CLU compiler. So we don't have a linker, but we can use the start up name. So that's pretty much like main in C.
Yes.
So now we can call the hello procedure, and we can have it leave the stop the process right there. So again, let's compile this. There we are. Let's check the junk file. That's the output from the compiler. So no errors there. That's fine. So let's start the CLU system again. We can load the new file. And now, this is a bit of a trick I find in some other files. I'm not sure if this is proper way to do it, but we can call gc pure dump with the file name. So now we have a new file called ts-hello, and that's a typical ITS program name. So we can run hello and get hello world. And that's the standalone program now. Okay,
Cool.
so that's all I wanted to show. We have a fully working 1978 CLU compiler and system. That's very nice.
Cool.
Yeah, very nice.
Thank you.
And-
So that's all I had. Do you have any concluding remarks?
I don't think so. I think it's great that you have a working CLU compiler, and that means people can play around with it, which is terrific.
Right. Yeah, I like to invite as many people as possible to explore and play around with this.
Yes, you could send us some information and we could maybe add it on our website.
Right. Sure. I'm happy to do that.
Yeah, that's a great idea.
Okay, so that's all, I guess. Short and sweet. Thank you very much, both Barbara and Dorothy.
You're
Yep.
welcome.
Thank you.
Yeah.
Thank you. Goodbye.
Bye.